So today we'll be looking at surds. And when we talk about surd, we say surds are square roots of non-perfect squares. Surds are square roots of non-perfect squares. Now let's understand the difference between square root and square, which I guess you already know. If you have something like this is what? So this is square root of a, right? If I have something like this is square of a, is it not? Good. Now the next thing we need to know is when we say perfect square. What is a perfect square? A perfect square is any number that when you take the square root, it will give you a whole number. This is what I mean. If you have something like this, the square root of 4 is what? 2, right? Meaning 4 is a perfect square. The square root of 16 is what? Meaning 16 is a perfect square. The square root of 3 is what? Sorry, the square root of 9 is what? 3, right? Meaning this is a perfect square also. Now, what is the square root of 2? 1.41. So the square root of 2 is 1.41. Is this a whole number? No, right? It's not. So is 2 a perfect square? 2 is not a perfect square. What's the square root of 3? 1.73. So is 3 a perfect square? No, right? Good. So we know the difference between a perfect square now and a non-perfect square. Now, surds are square roots of non-perfect squares. Surds are square root of non-perfect squares. For example, root 2. Since 2 is not a perfect square, square root of non-perfect square. This is surd. Square root of non-perfect square. Square root of non-perfect square. So these are surds. Do we get that? So it's not a big word. Anytime you hear surd, just square root of a non-perfect square. So if I may ask, is root 81, is this a surd? No, right? Because root 81 will give us what? 9. This is a perfect square. So this is not a surd. Good. So today we are going to be looking at how we can play around with surds. That's just it. So we're playing around with